All right, let's go ahead and get started. Good morning, everybody. Welcome to dtSearch Considerations. My name is Ben Redding. I'm on the Search Analytics team here at Relativity at the support team.
And my name is John Bartels. I'm also on the Searching and Analytics support team.
So real quick, before we get started, this is a webinar we've actually done in the past. We did it about 1.5 years ago, but we've added a little bit of new content. So if anybody attended that one, this might look a little bit familiar. Before we get started, I just want to take a minute to introduce our new software on 24. If you can see and hear the screen, please type yes in the question box. All right, let's go ahead and get started then. So for an agenda today, we're going to start just with a brief overview of keyword search, more in the lens of how it relates to dtSearch and how it differs a little bit. Some of the things that you cannot do in dtSearch, you can do with keyword search. So we do like to start this way just to point those things out and the differences between keyword and dtSearch. That way, if anybody has any questions on like when they should use either one, hopefully this helps address that. Then we'll get into dtSearch. We're going to start with just an overview of it. Then we'll talk about the alphabet file, what each of these sections mean and how you can edit that. We'll talk about the special characters and different considerations with those special characters. And then finally, we'll touch on when you want to make certain symbols searchable and when not to. So let's go ahead and get started. So keyword search leverages SQL. Every part of the index is stored in SQL. There's nothing that needs to be built. It's automatically created when you go to add data to your workspace. It's a search of the full text catalog in SQL. So if you see keyword search or full text catalog or FTC, those are all the same thing. One quick note, though, is that is-like and contains are not the same. Is-like conditions are actual SQL queries that are run directly in SQL, not using any index. They are essentially the same as if you've ever ran a SQL query and you type a column name like, and then you add the % signs. That's almost exactly what's happening when you use this in Relativity. So because of that, it's going to be taking the text directly as you see it. So anything where you're trying to search for it and you don't want to have it do syntax, is-like is definitely an option. One thing that we do want to say, though, is that contains is a more performance search than is-like. So if you have the opportunity to use an index, you definitely should, especially because is-like has none of the syntax options. So if those are going to be useful to you, make sure you're using them. And then you definitely do not want all your users constantly using is-like instead of contains. So if there's any field that does not have contains as an option, just go to the Fields tab in Relativity and enable it for the full text catalog or in the full text index. So one of the biggest differences between keyword search and dtSearch is how the not operator is ran. So you can use the not operator in keyword search, but you cannot start any query with it. And in combination with that, you can't use any or statement with it. And that's because keyword search needs something to anchor on. So if we take this first example here where we have apple, not pineapple, we actually get results because keyword search can look for apple, find any occurrences of that in the text, and then look for where pineapple does not occur and return it as a hit. Keyword search does not support just finding that document and returning the inverse of it. So anytime you have not pineapple or the other phrase, apple or not pineapple, we have no anchor in either of those. So keyword search can't actually run that. So this is a little bit different than how dtSearch does it. And we'll get into dtSearch in a little bit. But keyword search does have one piece of functionality that's a little bit different than dtSearch. Keyword search will not combine the fields. And so if we're trying to find an occurrence of apple, not pineapple in the extracted text alone, this will work really well for you. dtSearch actually will index all the fields as one giant blurb of text. So we do not separate out the fields with dtSearch. So let's take a look at this in practice. So consider this document that we have here, and this is a really, really simple case, obviously, but we have a OCR column, we have a recipient, we have an author. And so the SQL logic, if we're trying to evaluate Ryan, not Will, for the first column there, we'll actually say there is no hit because we're seeing Ryan, then we're finding Will, we're not going to return anything. In the recipient field, we're going to look and we're not going to find Ryan, so there won't be any hit there because it doesn't meet that anchor condition that I talked about. However, if we look at the author field, SQL is going to evaluate this out as we're going to find Ryan. Then we're going to look, we're not going to find Will, so that document will then get returned, even though those other two fields contain the word Will. So it's just something to keep in mind when you're using the not operator in keyword search. This can be really beneficial to you. And obviously, if you're using contains, you can specify the field that you want it on. So in this situation, if you wanted to find only in the OCR text or the extracted text where Ryan occurred but not Will, you could use contains rather than the full keyword search index. So keyword search does ignore stop words the same way that dtSearch does, and their position in the text is taken into account. So consider the query run in the rain. So we're going to get the same results with this as we would if we use the query run from all rain. Basically what SQL is doing is it's going to look for run first as an anchor. Then it's going to look for rain separated by any two words. Just keep in mind that any word can replace that, not just other noise words. So run in cold rain would also return. Just something to keep in mind, if you do need to modify these, I've included a list of all of the stop words, but they cannot be easily modified and certainly not across all workspaces. So you will want to use dtSearch if that's something that you need to search for. So if you're trying to find from or all or any of these other noise words that are listed here on the slide, you'll want to use dtSearch so that you can customize those or remove all of them if that is what works better for you. This list can be found both in the slide deck, which you'll get a copy of, or in our documentation, but also it is just a standard list of SQL keywords or SQL full text index stop words. So you can always search for those as well on any of Microsoft's documentation. Finally, keyword search also treats any single digit or single letter as a stop word, but any search for two or more letters or digits will return expected results. So just keep that in mind that, again, if you're looking for any single character, you will want to use dtSearch instead. And then there's also some special punctuation marks that are treated as stop words. So that's the period, the dash, the colon, semicolon, or either of the two slashes. Again, these are not easily customizable. So if you do want to search for any of those, you would want to use either is-like or dtSearch. For most of these, you can just use dtSearch. Some of them do have syntax considerations with dtSearch. And then finally, one final consideration with keyword search is that the @ sign is ignored if it's used at the beginning of a query. So if you search for @gmail.com, it's going to return the same documents as gmail.com. This is not configurable. It's just something to keep in mind if you're ever searching for that. Again, you would want to use dtSearch if this is something that you're going to need. And with that, I'll hand it over to John here to take us through a dtSearch overview.
Thank you, Ben, for the keyword search overview. Now we'll start to get into what I believe everyone is here for, and that is dtSearch. So let's take a few looks at the considerations here. Here are a few things to keep in mind when running dtSearch search terms. First off, if you build an index on strings that are longer than 32 characters and have no spaces, dtSearch will stop seeing at the 32nd character. So let's take a look at this example word on the slide here. The wildcard replaces the rest of privilege since it's at the 32nd character limit. If I search for the whole phrase privileged with ed at the end, it would not return as a hit because dtSearch will only index the first 32 characters of the word. Be sure if you have any search terms over 32 characters, remove that last portion of them and replace it with a wildcard so no search term is longer than those 32 characters. The next thing to keep in mind is that if you have more than one Boolean operator, such as and or, you should use parentheses. This helps to ensure you are running the search with the intended logic, and this is due to the fact that dtSearch evaluates or expressions before and expressions. It is important to note that keyword search evaluates and expressions before or expressions as well. Much like keyword search, noise words are ignored during dtSearch searches. A search term containing a noise word will return any document with any word replacing the noise word. There are many noise words that are built into a dtSearch index by default, so if you're getting over-inclusive results on a search, make sure to double-check the noise words list. Consider this example here, Statue of Liberty. dtSearch is actually looking for the word statue followed by an intervening word and ending with the word liberty. If the intervening word is a noise word, any word can take its place. Also, if punctuation exists in your search term, dtSearch will interpret that as a space as well. This can mean that our search terms can be split up into multiple words and noise words being replaced with any intervening word. All right, let's take a look at some dtSearch syntax in this next slide here. All right, here are the effects of proximity and its effects on dtSearch. So dtSearch can make use of proximity searches. For this, we use the W/N symbol as the connector. When using a proximity search, it is important for at least one side of the connector to be a single word or phrase. One side of the proximity can also be a series of words connected with the OR operator. Because the logic searches each term connected with the OR, the engine is able to join the results. We often see ambiguous proximity searches that error out. These searches often contain logic that do not make sense to the engine. The proximity search is looking for one word or phrase occurring within a number of words of another word or phrase. Looking at the first example here, what we really want is an occurrence of slept when it's close to the word dog with the phrases hound and Rottweiler in the middle. As this query stands, dtSearch will try to search for dog within 5 of hound, and it then will look for slept within 2 of Rottweiler. Next, it will try to combine those two phrases. It will either give inaccurate results or it will simply return an error. To get around this, we need to make sure that each subsequent term carries through its distance from dog. This way the engine can first find an occurrence of hound within 5 of dog, then find Rottweiler within 15 words of that result. Finally, it'll expand to find dog no more than 2 words away from Rottweiler. In short, each term separated by a proximity needs to satisfy all conditions of each proximity connector in the entire string. Keep in mind that proximity connectors are symmetrical. So dtSearch will look for dog and try to find an occurrence of hound within 5 words on either side of the term dog. Another important note on this is that dtSearch combines all of the text of the documents returned in the saved search as one long string of text. Because of this, proximity will match between fields. This means that if we index the extracted text field with another field after it, it can stretch the proximity across those 2 fields. For this reason, we recommend only building a dtSearch index on the extracted text field when using proximity searches. dtSearch handles the not operator differently than keyword search. In general, the not expression is used to reverse a search term's meaning or exclude certain terms when other terms are present. Unlike keyword search, you can start a dtSearch term with the not operator to return all documents that do not contain that term. If you use the not operator with another term, meaning that the search does not start with not, you must use the and or Boolean operators with it. It is important to know that you can use proximities with the not operator as well. This will find occurrences of a phrase when it is not used with another term. Here you can see that not within is not symmetrical. Let's look at these 2 queries. In the cat not within 20 dog search term, dtSearch searches for cat and excludes cases where cat is too close to dog. However, in the dog not within 20 cat request, dtSearch searches for dog and excludes cases where dog is too close to cat. So it's important to define specifically what you're searching for. All right, next we have a list of special characters and what they do in dtSearch. You'll be getting a copy of this slide deck after the webinar, so feel free to reference this slide again. I'm going to just go over a few of the less obvious special syntax characters, and then we'll touch briefly on wildcards in the next slide. So besides and, or not, and proximity searches, we can use special syntax here. For one, fuzzy searching can be used to find misspelled words or names. And then there's phonic searching as well, which is a bit unpredictable and only works with English documents. It looks for a word that sounds like a word you're searching for and begins with the same letter. For example, a phonic search for the word Smith will also find the word Smith with an E at the end, or in place of the I with a Y in the middle. All right, now let's take a look at wildcard searching in dtSearch. There are a few different ways to use wildcards in dtSearch. You can use a wildcard at the end of a term in order to find any number of characters after first finding a certain string of characters. This is the fastest of wildcard operations. You can use a wildcard at the beginning of a string to return results with any number of characters preceding the string. You can use a combination of a leading wildcard and an ending wildcard. But be careful with these search terms. Due to performance reasons, we do not recommend setting up terms with a leading wildcard. In conjunctions to performance issues, these searches tend to be very slow and can time out or cause errors. If possible, we recommend adding a few leading characters. You can also use the question mark to search for any single character. Keep in mind, this will only work for any single character, so searching for APPL question mark would match with apply and apple, but not the term apples. You can use a wildcard in the middle of a string to return results with any number of characters in the middle as well. Any search with any wildcard near the beginning of the terms will slow the searches. So keep this in mind when crafting more complex searches. Sometimes you may need to get results, tag them, and run another search across those results to improve performance. All right, here we have our emoji slide here. We had a few difficulties formatting this or converting this to our On24 software, so apologies about that. So here we're gonna talk about how you can search for special characters, including emojis. Unfortunately, with dtSearch, it is impossible to make other characters above 10,000 on the Unicode table searchable. We'll dive into what this means later in the webinar, but with this in mind, it is only possible to search for characters under that range. An additional issue is that following characters cannot be made searchable in dtSearch index. We have the hashtag, the pound sign, the apostrophes, parentheses, etc., etc. These also happen to be very common emoji characters. Examples include smiley face, frowny face, and winking smiley face. The only workaround is to use the is-like condition on the field you're using for the emoji. This will take the literal characters and attempt to find the hits.
All right, so let's take a look at the alphabet file. So the alphabet box in your dtSearch index displays a list of all the characters and how dtSearch is classifying each one. So dtSearch has 4 separate sections. It has the letters, the hyphens, the spaces, and the ignore section. In the letters section, this is going to be anything that is searchable. So this is all the standard characters that you'd expect to be able to find in your documents. In general, this is going to be the lower and capital version of every letter, so A to Z, as well as all of the digits, so 0 to 9. And remember that any single digit is still searchable with dtSearch. The hyphen section does have a little bit of special processing. It doesn't kind of fit in the letters section or the spaces or the ignore section. If you're searching for the hyphen, you will get any hits where the hyphen exists or doesn't exist. And so the benefit of this is that you can find any time that, there's often times, especially in English, where we have the same word that can be hyphenated or not be hyphenated. So by default, this makes it so that you can search with one of those terms and return both hits. If you do want to find situations where it's just the hyphen, you'd want to move this hyphen character into the letters section. Another note on the hyphen is that by default, only the small m dash hyphen is actually included in the dtSearch index. If you are searching for the larger hyphen that comes from like Word or other word processing engines, you just need to add an example of that other text to the letters section or to the hyphen section. By default, this isn't really something that we tend to see as an issue, since most processing engines, when pulling the data into relativity, will automatically convert it back to the standard small hyphen. The spaces section, I think, is a little bit misleading. These are not actually spaces. They're actually characters that cause word breaks. And so the difference there is that it's not really right to think of these as spaces so much as they are just separating the two words out and telling us this is where the word ends. So, for example, if you classify the period as a space character here, which it does by default, dtSearch is going to process U period, S period, A period as 3 separate words. This can impact your proximity searching, so it's really important to know when you're searching for your proximity if you're going to have something in here and pad the proximity accordingly. If you do need to index these characters, you simply remove them from the spaces section, add them to the letters section, and continue. Just note that you can't add them to the hyphens section. Only the hyphens are allowed to be there. So if you do want to, it has to either be kind of this is indexed or this is not indexed, or you can add them to the ignore section. So the ignore section is for any characters that are completely disregarded when we're processing the text. An important note on that is it's anytime dtSearch is processing text into the engine, right? So anytime if we're doing an index build, it's going to ignore it, or if you're adding a search term, it's going to ignore it. So if you were to add any one of your numbers or letters to the ignore section, when they're in a search term, we're going to completely ignore that they even exist. So one example of that is anytime that you're trying to search, if you moved the 0, for example, into the ignore section, if you're trying to search for any kind of proximity that has a 10 or 20, 30, it's going to look at it as within 1 or within 2 because it doesn't see that 0 at all. So be very careful with the ignore section. By default, we have everything in there that you want. All the extra character or all the extra text that is in a document, such as tabs, hard returns, that kind of thing, are already in there. So you don't usually need to modify it in any way. Generally, you only are going to be flipping things back and forth between the spaces and the letters section. One other note on that is that only characters in the Unicode range of 33 to 127 can be modified using these 4 sections. So if you want to do anything outside of that 127 range, you will need to add another tag to the index. So this is something we'll touch a little bit later on in another slide in detail about how you go about doing that. But just keep in mind that that's going to be anything that is a more non-standard text. Like the paragraph sign, section symbol, anything outside of like the US dollar sign, so British pound, anything like that. And then one final note is that there is another section that we didn't mention here that is the CJK range, and that is your Chinese, Japanese, and Korean languages and anything built on those languages themselves. So those are all standard. You don't usually need to modify anything like that. I think I've only seen a handful of situations where that's useful. If you fall into that category, you likely already know that you need to do that. So to make most symbols searchable, you just need to modify that alphabet file with dtSearch. So you're going to take the symbol, you're going to remove it from the spaces section. So that's that screenshot all the way on the right. Then you need to add it to the letters section. So that's what we have in the first 2 screenshots on the left here. So just keep in mind that you always want to start with a space before each instance of the symbol. And then the symbol does need to be there 4 times. This is just for formatting reasons. It's just the way that dtSearch processes this alphabet file into the index. In general, one kind of tip that I have is just always make sure that there's a clean line on the left side of the letters section. So you see in these screenshots is a space between each of those letters, and then there is a leading space as well. If you don't add the leading space, then it's not going to work. Once you make these changes, you do have to run a full build on your index, and anybody using it needs to be made aware that there is special characters or special processing going on here. So one kind of tip that we have with this is that you want to make sure that you are always having a separate index anytime you're modifying the standard index. And that way you can always flip back and forth between them, compare results, and you can make sure that everybody knows exactly what it is that they're searching for. Sometimes it can be useful to say, like in this case, we made the @ sign searchable. So it can be useful to add that to the title of the dtSearch index. So maybe dtSearch with parentheses, like symbols searchable, something along that line so that you know exactly what it is that you're searching for and there's no misconceptions about what that index is supposed to be finding. So there are some symbols that can never be made searchable. This is because they're reserved for syntax. So this is going to be any of those that we talked about earlier on that slide, which is why that can be a useful reference for you. So particularly with like the % sign or the and sign, those are the ones that we tend to see most often. You do need to use a regular expression to get them to return. So there's a lot of back and forth about this, but really the best practice is to use the regular expression. It can often be over-inclusive, especially if you made multiple symbols searchable, but the regular expression really is the best way to do this. And so to create your regular expression, every regular expression in dtSearch has to be encompassed by quotes, and it must have the double hashtag at the start of it. So here we have an example of that. And so if our search term is P and G, the regex that we're going to end up using in dtSearch is going to look like this. And so we've color-coded it with what's kind of standard, what's the letters, and what's the symbol character. So here, the green characters that you're seeing, those are your standard, every single regular expression has that. That's what tells dtSearch that this is a regular expression. Keep in mind that regular expressions are search terms by themselves, so you can include them in proximity searches if you want to. However, they are going to likely hit timeouts, so you may need to adjust those accordingly. Moving back to the example here, we have the letters P and G. Those are in red. Notice that they are lowercase. Any regular characters that you're searching for in dtSearch must be in lowercase. The dtSearch index, by definition, is not case sensitive. That's why we have the two sections of the letters section of the alphabet file. It converts everything to lowercase, so you don't need to worry about the regular expression not matching. The final piece of our regular expression there is the blue/W. This is telling us that we want dtSearch to look for any symbols. So /W is regex, meaning any symbol character. And so because of that, we will be only searching for characters that are searchable and are in the symbol classification, which is %, $, hashtag, and so on. So as long as you're making an index specifically for searching for the %, specifically searching for the ampersand, you should be okay here. You shouldn't have any over-inclusive results.
All right, let's take a look at some of the dtSearch index creation considerations. In this slide, we'll take a look on how to give you some quick optimization tips before creating your dtSearch index. So first off, it is necessary for the searchable set save search in the dtSearch index to only contain authored content fields. This would be including such things like the extracted text field. Any other fields will bloat the index because there will be no need to return search hits on them. These are also fields that you typically would not want to search on in a dtSearch index. You might start seeing over-inclusive hits on documents that do not actually contain the terms in the body or the extracted text of the document. This will cause confusion, and reviewers will likely question why they got a hit. For example, a hit in the comments field that isn't actually shown in the actual extracted text of a document. As a workaround, you can still search on any other fields via filtering and save search conditions. Ultimately, including these extraneous fields in the index are not useful because they are usually searching for what is in the actual body of the document. It is important to note that the All Documents in Workspace default save search upon creating a dtSearch index includes all fields that are included in the full text index, also known as the keyword search or keyword index. Double check these fields in the Fields tab to determine if you'd like to include these in your dtSearch index. Also, large documents with authored content fields that are indexed can significantly impact the speed of your build. So for example, if you're building a dtSearch index with just the extracted text field, double check the size of this field by sorting by the largest documents. If there are many large documents, then your build is likely to take longer. A dtSearch index worker can only pick up one subindex at a time. Beyond optimizing your dtSearch index workers to ensure your server has enough RAM and cores, which is 1 core and 2 gigabytes per each additional agent on the agent server, the subindex size needs to be optimized. In our performance testing, there's usually not much benefit to lowering the subindex size, and you only need to raise the subindex size when there are more than 40 subindexes or 10 million documents.
So earlier I mentioned the additional letters section, so let's take a look at what that looks like. So the regular alphabet file is going to control processing of any characters in that 127 range, which is any of the ASCII characters. Characters above that range, like the section sign or the English pound symbol, are going to be processed according to the Unicode standard. So to make these searchable, you actually have to add them with an additional tag that's not there by default. So the additional letters section it's not going to accept accept any range of Unicode characters. So each character needs to be entered specifically with a space between them. It does not need to be listed 4 times, and it does not need to be added to any of the other sections of the alphabet file. So we're not going to add it spaces, ignore anything else. For this, we're just going to be adding it as a tag. The formatting is really important, though. So this needs to go below the CJK range in your alphabet file, and the additional letters need to be written in the way they are in the screenshot here, where there's no space between additional and letters. Make sure you're capitalizing it correctly so that dtSearch can recognize what that is supposed to mean. Then you'll enter the equal sign followed by a space followed by whatever the character is. So again, just like we had earlier, we want to make sure always that leading padded space character, put the range in there. So you might be wondering where I got these from. 00A3 for the pound sign is just the Unicode abbreviation of that, or really the Unicode representation of that. And you can find this on the Unicode table. It is a free, you just Google search Unicode table and you can get it. And these days you can tend to just search for the Unicode pound symbol, and Google will just return what that code is. If you have any questions on what the code should be or where you can find it, anything like that, please reach out to either the solutions team or the support team here at Relativity. We'd be happy to point you in the right direction or show you what that means or demo this for you in your own case. Once these are indexed, you can then go ahead and search on them just like you would. You don't need to use the Unicode standard for them, though. So once you have that entered in the alphabet file, dtSearch will recognize the pound symbol as a character. So if you include it in your syntax, it will work. If you do not include any of these additional characters, but add the section, pound sign, etc., to your search term, it's just going to completely ignore it because it doesn't know how to handle it. It won't treat it as anything.
All right, so there are certain cases where you don't want to make certain characters searchable, and we'll go over that in this next slide here. So you do not need to make symbols searchable if you know that the search string you're looking for sometimes contains symbols, but at other times contains spaces. For example, you may need to search for the following strings where there may or may not be a symbol separating each term. The point here is that if you need to look for a very specific phrase that has a specific symbol embedded in it, that is a situation where you would want to make that symbol searchable. Phone numbers are a good example of when not to make a symbol searchable, because the same phone number might have hyphens, periods, spaces, or some other symbol separating each numeric phrase. It's essentially not making any use of indexing those characters because they all treat those symbols as spaces.
There are some characters in dtSearch that you cannot make searchable. We have them pulled up on the screen here. So any of these characters, if you're trying to search for them, you need to be real careful with how you're going to be doing it. Some of the symbols can be found using a regular expression. One note here is the ampersand, the @ sign. You can make it searchable, just make sure that you're not auto-recognizing text. So just with the default standard, you can't do that. We did use that as an example a little earlier just because it stands out better. Any of these symbols that we have here can be found with the regular expression. They are all classified as symbols with the regular expression, so that /W/W, I should say, will work to return them. If you do need to search for them, that's recommended the best way. I included an FAQ here. We hear this all the time where someone says, well, I added the % to my alphabet file and I removed it from the ignore list. So why was I able to bring that back? And so this is kind of one of those it just happens to work because the % is a fuzzy character. So that means it's going to be looking for anything at the end of apple that's matching in that place. And so when it's doing that, it's finding a character at that spot. It's not actually looking for the % sign. So this is kind of one of those, it gets into how these characters are actually indexed. So if you add any of these to the alphabet or the letters section of the alphabet file, like we talked about, the engine will go ahead and index them. So when we're ingesting the text and we're going through creating the index, it's going to actually add all of those to the index files. But in our search terms, we can't actually search for them, because as soon as you try entering it in, it's going to interpret it as syntax and take whatever that syntax means. So if we were looking for APPLE question mark, that would also work the same way that the %sign is, same with the wildcard. But you could end up with over-inclusive results, especially if you're using like a wildcard, since it'll match any number of characters after Apple. So the best way to handle these is really using a regular expression, or is like SQL is like if you need to. Just want to take us through some common issues and myths that we see. These are just kind of our observations that we see, is kind of the things we hear most often here in support. So we just wanted to touch on them. The first being searching for noise words. So we often get calls where somebody is searching for something and they're either not getting hits or they're not getting expected hits. And so the reason for that is that if you're searching for noise words, keep in mind that anything is going to match in the place of that. And then also it's only a single byte of text in the noise word list. So sometimes that can cause a little bit of goofiness with how you're searching for things. Just make sure that when you're searching for any noise word character, you're removing it from the noise word list first. Sometimes if there is words that you continually find that you're always searching for them, you don't agree with them being in that noise word list, you can go to the instance settings, search for the default noise word list for dtSearch. Under the description is probably the easiest place to find it. And you can modify what we're using as that default file for our index builds. Another reason you might want to add to that is if you're doing a lot of your own like company, like reviewing documents from your own company or something like that, you may want to just completely ignore, count any of your company's names or abbreviations as noise words. You can always modify that. You can add whatever you want. It can also be useful to add noise words from other languages if you need to. So you can do all of that either at the instance level or for each workspace. Just remember, whenever you're modifying the noise word list, you do need to run a full build of the index in order to apply that. Kind of in conjunction with that is searching for syntax characters. Kind of as we mentioned, make sure that if you are searching for any of them, you're using a regular expression. It just can be really useful to look over all your words, with a quick overview, make sure that there's nothing in there that is either a noise word or a syntax character. If there is, just know that you need to handle that in a specific way. Another one is that you're searching for proximity between multiple fields being indexed. And so generally that's not the intention. Generally you're trying to find a sentence or list or a few sentences inside your extracted text, so specifically the authored content of the document. But because dtSearch is taking the entire thing as a giant blurb of text, you need to make sure that you're only indexing the extracted text field by default. And so that kind of ties into the next bullet point here. Oftentimes we see the all documents and workspace search being used. It's something that it makes a lot of sense, right? When you're going to build your dtSearch index, you want to make sure that you're going to include all of the documents, and this is the first item listed in the saved search. So you just grab that, go ahead and build your index. But what this is actually doing is taking all the fields from your keyword search index and including them in the order that they list, like the order that they were created, because it's going off of artifact ID, in the dtSearch index. And so when you're looking at this, and if you're seeing like, hey, proximity is not hidden correctly, you want to kind of check and see, make sure that the all documents and workspace search isn't being used. Or if it is being used, you may want to remove some of the fields from the full text catalog, especially if you have added anything to enable the contains character. Some of those can be really odd fields, right? Like if you have a specific workflow where you need to search on this specific field, you might add it to the keyword search index to enable the contains operator, but you definitely don't want that in dtSearch. Just be real careful about what you're actually indexing. Oftentimes you just don't realize what fields are in there. And then just from a practical standpoint, if you're using this all documents and workspace every single time, you're going to be including extra fields in your dtSearch index, which is just going to increase storage costs because it's just going to make the index larger than you actually intend it to be. Sometimes there's duplicate information in there, and since it's one giant blur of text, that's not very helpful. Then a few myths that we have. One of them is that quotes are always necessary. And really, quotes are only necessary when you're searching for Boolean search terms. So that's going to be your and, or, not, etc. So if you have any of those in your search, you need to remove them from the noise word list and then use quotes to tell dtSearch that you want to use that word as the character or as the word itself and not as the syntax Boolean. And one example of that bear down with quotes is not the same as bear space down. And especially if we have, or sorry, bear down is the same as bear down without quotes. But if we have bears or down, that is not the same as bears or down without quotes. In one situation, we're looking for a phrase. That's when we have the quotes, we're telling the engine, I want this phrase coming out of my text. If we include the or in there without the quotes, we're saying anytime either bear or down occurs in my text, return the document. So you can see how those would have very different impacts on your results. So that wraps up the webinar that we have for you today. John and I are going to be here for some questions for quite some time still, so feel free to enter anything in the box. Just give us a moment here. We're going to look through all the questions you may have already entered. We'll answer them in the order that they came in. But if you don't have any questions, thanks for attending. We really appreciate it. All of your credits can be found. There's a link here that you can look and see where you're at. But thanks for attending, and we will account your credits towards your certification. All right, so the first question that we found is, will a search for APPL question mark return documents containing APPL, or does it need to match the question mark to a character? So it is a wildcard character, so it is trying to match it. If you don't know whether it exists or not, that's a case for the fuzzy searching. So similar behavior with the %sign and fuzzy searching, but that's what that's intended for. The question mark is saying, I know there's a character here, I just don't know what that character is, or I don't care what that character is. Another question, if two words are hyphenated, are they considered one or two words from a proximity standpoint? Remember, by default, the hyphen essentially doesn't exist. The engine is processing that in a special way. So if it's seeing it and two words are hyphenated together, that's actually going to become one word as far as proximity is considered. If you want it to be considered separately, you would need to move the hyphen to the spaces section. Or if you wanted the hyphen to be considered as text, then you'd need to move that to the letters section. Are quotes similar to hyphens? Is it necessary to modify a Word version of a quote to a text editor version? It is really important when you're entering quotes for regular expressions that they are the standard version, the non-curly quotes, but the rest of the time they are going to be interpreted as regular quotes in the text. There's a question about whether we have a dtSearch query available to find illegal characters that cause a document to be removed from structured analytics processing, like the emoji characters. We do not have anything like that. You could theoretically use like is-like, but it would be better to just let the engine run on that for structured analytics, especially with the changes that we've made to it where we'll ignore that character and continue on processing it anyway. So we would strongly recommend just including that document in your structured analytics set and letting the CAT engine, analytics engine, remove it if necessary. There's another question here about why you need to add the symbol to the top and bottom of the letters section. It's just one of those processing things. It's just the way that dtSearch is reading through that alphabet file, the way it's parsing through it. It's just something with formatting. So whenever you're adding it, add it to the top and bottom.
All right. Can you build this? Can you build a regular expression into an str? STRs use dtSearch indexes, so anything you can search in a dtSearch index, you can also use in conjunction with a str. So any type of search you can run safely through a dtSearch index. Like I said, an str will pick that up as well. The best way to go over a search for email addresses. So my recommendation would be to use the auto recognition feature in dtSearch. You can look more into our documentation on that, but essentially what you do is you would turn on, before building your index, the yes section for the feature of using auto recognition, which can also do credit cards and phone numbers and things of that nature. And you would simply just type mail, and then in parentheses you would type any type of email address that you would search for, and it's able to kind of alias it and pick out the email addresses you're searching for. Is there any plan to include a front-end tester based on the current index with the test text so we can validate, verify the dtSearch syntax, especially regex? We don't have that right now, but I'm happy to submit that as product feedback for the future. You can also use our community site where you could submit that as an idea, and the more upvotes you get, the more likely it'll be implemented. What is the best way to search for terms where there might be a space / hyphen, etc.?
So the hyphen is going to be ignored by default. So 555-2468 will be seen the same as 555-2468 without the space. So if you're trying to search for it, whether it exists or not, you kind of have to make two searches there, or you can add it to the spaces section if you're trying to find where it's a hyphen or a space. So essentially, like our recommendation would be 555 space 2468 or 555-2468. And so the second term there with the dash would include both if it exists, if it doesn't exist. It's one of those kind of goofy situations with hyphens. You can also include the wildcard there if you wanted to, just to help you keep track of like the hyphen being there, but you don't need to. Also, you can always include the equal sign instead if you're looking for specifically for digits. So there's a question here about how when you're studying for the RCA, you're making the ampersand or the and sign searchable. This is one of those situations where like you can make it searchable, but it's going to be seen as a symbol, and so it's really best to use the regular expression for that. This is just kind of our best practice. So as we're going through the webinar, we're going to include that in what we consider that you would use a regular expression for. We actually do have a community article on this if you want to grab that with steps to make it searchable and how to create the regular expression and what kind of the different impacts are on that. It is one of those kind of special characters that have a little bit of different processing with them.
So what are some of the most common instances where you recommend using keyword search instead of dtSearch? Keyword search, when you load data into your workspace, it instantly is loaded into the full text index. So it's available right when it's available right to search on it when you load data in. Whereas dtSearch, you have to spend time setting up your searchable set, building your index. Also, it's worth noting that dtSearch has to communicate to over a network to access the index, whereas keyword search is built right into the full text index. So really the one advantage being it's loaded right in there. You can search right away, right when you load data into your workspace, whereas dtSearch, you have to build an index. We have the email to from CC, BCC, OCR text, and extracted text in our dtSearch Save Search. Should we take out the email to from CC and BCC fields? Well, it's honestly up to you what you want to search for. If you're searching for just email addresses, you can set up your own specific dtSearch index for email addresses, and that way you can now have use the auto recognition feature to search strictly on your email address fields. Then you could create a separate dtSearch index on just the extracted text when you're searching for terms in the body of a document. So you can kind of flip back and forth between the two indexes and kind of analyze exactly what you want to search for. You can combine all of them together if you just want to search all of them together. But at the end of the day, it's really up to you what you want in your dtSearch index. You have control of what fields you build the index on and what you're trying to search for.
To answer the second part of that, the OCR and extracted text fields, they tend to be either one or the other is populated. If that's the case, then you'll have no issue including both of them in your text. Just be careful if they're both populated, including the OCR field, just because there could be slight differences in the text. And if you're only looking at the extracted text, you may have a hit that you don't know why you're getting it. But in general, you can always include both the OCR and extracted text fields without any issue. You should really only move the OCR data into the extracted text field if that works for your workflow. But that can have like other impacts if people are not aware that that text was OCR'd. Just make sure that you make your case team aware of that.
Could you explain a bit more about the bear down in the miss section? So essentially, when you use dtSearch, it searches for the exact phrase. So it's unnecessary to put quotes around a phrase unless you're using the Boolean operators and or. So if you're searching for bear and down and you actually want to pull back the exact phrase bear and down, then that's where you'd want to use quotes. If you're searching for bear and down as a Boolean operator, then you would be searching for the terms bear and the word down when it would come up. So essentially what the quotes do is it makes sure that you're searching for the phrase you want. If you don't use the quotes with the Boolean operators, then it's going to use those operators as part of the connectors or search for those two terms separately, whether you use and or. So it's really only important to use the quotes when you're searching for a phrase with some type of Boolean operator in it.
The next question here is kind of parallel to that. So what is the downside to using unnecessary quotes? This is kind of more of just one of those like formatting things. There isn't really any downside if you're including it on every single phrase. It's not going to hurt anything, with the exception of if you are intending to use Boolean characters and you're adding that there, we're going to interpret it as a word. And so like that can hurt you if like and is a noise word and then you're including it in quotes. We're going to be looking for any word in the middle of it. So it's not giving you the exact phrase that you think you're searching for. So in general, we say to pull the quotes out just from kind of a best practice. It helps make you aware of that, help keep in mind what you're actually searching for. It's just one of those, like, it often can clog up the search terms as well. So it's more of just a like best practice when looking at it. It makes it easier to interpret what the search term is. But as far as dtSearch is concerned, there's rarely little downside to including them if you do. There's a question on will the PowerPoint be emailed? You should receive a copy of it automatically when the webinar completes. You can also download it in the quick links in On24. Should be on your screen somewhere. If you don't get it, feel free to reach out to the certification team. They can get you a copy of the PowerPoint, but you should get that either downloaded on the screen or as a follow-up once the webinar completes. Do you recommend removing regular expressions from the dtSearch index? I'm not quite positive what that means. Regular expressions themselves are a form of syntax, so you can't really remove them. They're kind of more of like how you're adding, like what you'd be adding to your search phrase. But if you are talking about like regular expressions as in like noise words or things people say all the time, you certainly can. You just want to be aware that like the only real point of the noise word section is to reduce the total size of your index and to remove a lot of that bloat that comes out of it. Basically what that means is that imagine any of the words you can pull out of a sentence and still understand what I'm trying to say. That's kind of the point with noise words, is that we don't really need them there. Their position in the text should be accounted for as far as proximity is concerned, but you can strip them down to their base level of just saying like, hey, there's a word here, and move on to the next thing. So it uses a lot less space when you include noise words. So it really comes down to what you want to do. It may be some testing when you're looking at your like dtSearch index sizes. If you have a lot of space and you're not concerned about that, then I wouldn't worry about it. If it is something that, like you guys want to look into, feel free to reach out to either support@relativity.com or solutions@relativity.com. I think both teams would be able to help you with that if you had any further questions on it. So there's another question about what is the best format for searching multiple search strings using the Save Searches view. So really the best way to do this if you have multiple search terms is your search term report, and you want to do report and tag. Then you can go back to your Save Search and pull in the field conditions for that for the search term report that you just ran. If you need to include it on the fly, you can only enter one index search condition at a time. So if you need to have multiple search conditions that are completely separate from each other and are not using like an or as a combination or like as the Boolean phrase for that, you can always nest a Save Search. So make one Save Search with one index, or with one index search term, and then nest that in another search and add another index search term on top of it. Just be careful when doing that. Oftentimes, you're kind of trimming down already a pool of documents so you can get unexpected results. Our best recommendation would be to use a search term report. That's what it's designed for. So there's another question, not a dtSearch index question, but a searching question. If you search the long text field for is like John Doe, why would it not return john.doe@email.com? The answer for this is that, remember, as we talked about, is like is extremely literal. So it's looking for that exact text occurring in the document. So in this situation, you're searching for John space Doe, but the email itself is John period Doe. And so SQL is not going to consider that a hit. So if that's the case, you may want to search for is like John or is like Doe. Or again, that would be a situation where you'd want to use dtSearch instead. There's a question here about, do we have any specs for SQL servers when supporting large workspaces in order to ensure optimum performance? What I would say in this is that we do have a guide for very large workspaces. Anything that you need to know about the full text catalog would be listed in that document. In general, like if you're already supporting the large workspace itself, the full text catalog isn't going to take up all that much space in relation to the larger workspace itself. There is also an article on maintaining the full text catalog. Generally, you may want to just run more regular optimization of the full text catalog itself, run regular defrag on it, all kinds of that, things of that nature. And you may want to try and index fewer fields if you already know that you're going to have a huge workspace. So maybe try to keep it narrowed down to just extracted text instead of like group identifier, control number, and extracted text, something of that nature. There's a question about putting a wildcard at the beginning of a term. Is it something to avoid only if the term and wildcard is at the beginning of a string, or if the term with the leading wildcard is anywhere in the string? Keep in mind that the leading wildcard on each individual search phrase is what's going to make it take longer. So it doesn't really matter if it's at the beginning or the end. dtSearch is evaluating it piece by piece anyway. So it will have a larger impact kind of right off the bat if it's at the very beginning, but it doesn't really matter if it's anywhere throughout the string. You want to avoid leading wildcards as much as possible. So you may need to kind of reconsider that, and as we suggested, do just a single leading wildcard search term, get the results of that, tag them, and then use that in a saved search in conjunction with the rest of your search phrase.
You mentioned that proximity searches will run across multiple fields in the dtSearch index. Are the fields concatenated together in the order that they appear in the list? That is correct. So if you are building it on the email to, from, and CC fields, your dtSearch index, if you have email to at the top, then email from after it, and email CC after it, it'll build the index in that exact order. So something to take into consideration, that the last document in the list of the to field will be the end of that field there, and then it will continue on into the from field, which is next in order in the list of fields in the saved search. How can I see what fields are being indexed in the all documents in workspace default saved search? If you navigate to the fields tab in your workspace, I would go to the all views view, or all fields view, and there should be a column or a field called include in text index. I would filter on that column and filter for yes. After filtering on that column, you should see a list of all the documents in workspace fields. All those that are set to yes are indexed in the all documents in workspace default saved search. It's also important to note that these are also the fields that are put into your keyword search or keyword index as well.
There's another question about, is the proximity search terms supported for finding words within phrases of each other? For an example, bus within 0 of bus driver. Yes, it is. You can definitely use any search term or phrase. Just keep in mind that one side of the proximity or the other needs to come down to a single word or phrase. But dtSearch is going to evaluate a phrase out to a single search term, essentially. So bus driver, the engine is going to see that as a single, like, I'm seeing bus driver. As long as that occurs in the text, I just need to look in proximity on either side of that. It looks on the end, though, as far as like the proximity is concerned. So like if you're trying to do, like bus driver drives or bus driver lives over there or something, and you're doing a proximity with like bus and live, it's not going to count driver if that's in a phrase. So it's the end of the phrase on either end. So just think of like bus driver as one word in that sense, if it's being treated as a single phrase. Let me know if that answers the question. I'm not sure if that was super clear. Sometimes it's easier if you have an actual example, like in your text to search on. If you want to talk about that in more detail, feel free to let us know, submit a ticket, and we can schedule a call with you to go over that. There's a question about when creating a search off a saved search with only the extracted text field, it will also include any field that is marked to include in text indexing, even if it is not in the saved search. So I think you're just confusing the all documents and workspace search with any other saved search. If you are using a saved search you have created, it will use whatever fields you have returned in that saved search for the index. The only time that it will use all the fields marked as include in text index is when you use that search that's at the very top that has the kind of like greater than, less than, all documents in workspace. So just kind of avoid that very top search, and everything else will be exactly as you planned it with whatever fields are returned in the saved search you choose. There's a question on what do quotes do to hyphens, and so essentially nothing. The hyphen is done during pre-processing, or really during processing when we're pulling the data into the dtSearch index. So because of that, the quote is modifying, are we seeing this as syntax or not? The hyphen is not really syntax in that case. It's saying how do we handle the hyphen character when it occurs in documents. So by the time you're searching on your index, the hyphen has already been handled, so it doesn't modify it in any way. There's a question, so to search hyphens, they have to be in the letter section. What is the point of the hyphen section? So by default, oftentimes in language, the hyphen can exist or not exist, but it's rarely ever actually spaced out. Like usually if people are including the hyphen, they either are removing it entirely or including it in the word. And so by default, the hyphen is going to allow you to search, basically consider both of those options. So if it exists in the word, let me know if it also just doesn't exist in the word. It's a little bit different, right? Because like the spaces section is a word break. So if you add it to the word break in the spaces section, those two words will be treated separately, and that can impact your proximity, search terms, etc. If you add it to the letters section, you can actually search for just when the hyphen occurs itself. So you're saying like, I only want to know when the hyphen occurs in my text, not when the hyphen is there or if it's completely missing. Just know that the hyphen doesn't match a space. So if I have like Ben-John, or Ben-John, those are both going to match with a search for either of them. But if I have Ben space John, that will only return if I include Ben, a space, and John as my search term. So it's just a little bit different. It kind of gives you two options with the hyphen instead of just one, like you have with either the letters or spaces section.
Does the auto recognize feature for mail and then in parentheses the address capture exchange data? That feature will recognize any email that's in some type of email format that's indexed into your dtSearch index. So as long as that exchange data is included as a field in your dtSearch index searchable set, and it's been built with the auto recognize field, the mail auto recognize field will in fact work. What happens if you search for @gmail.com? As long as you didn't index the special characters as the @ and the period here, it will simply search for space Gmail space com. So if that's what you're searching for and you're trying to search for that, then that's exactly what will appear in your results. So what is the best way to search for terms with a leading or following underscore? The underscore is treated as a character, so you can treat it as any other letter. When searching for the percentage symbol, do we need to add the percentage symbol to the character list before searching as a regex? Yes, you need to remove it from the special character section and then index it properly in the alphabet file section or the letter section. That way you can then use the regular expression to search on that symbol.
Going back to the spaces/hyphen question, was the ultimate answer to search for both variations of 446-789 or 446 space 789? I'm sorry that was a little bit confusing. Yes, the ultimate answer is that you want to search for both 446-789 and then also search for 446 space 789. Only exception with that being if you want to be able to find both of them, like if you're not looking for an occurrence of 446,789 with nothing in the middle, then you can just index the hyphen as a space character, and then you don't need to have two variations. If you're still confused in that, please let us know. I want to make sure that we get that answered for you. It might be better to do it on a call or with some examples. So feel free to call in to support or shoot us an email. We can address that with you. If we run STRs and save searches at the same time that are accessing the same dtSearch indexes, will it cause latency issues? So the search indexes are capable of handling multiple requests at the same time. Really, the limiting factor there would be the search engine, like the dtSearch search agent. As long as it has cores available and it has RAM available to run multiple searches at once, then you won't see any latency. In general, search terms are ran pretty quickly, so you are not going to notice, in most cases, you're not going to notice anything bad. Certainly not to the point where we would recommend ever being cautious because of that. Really, it would only be in like the largest of workspaces that you could run into any kind of noticeable impact. In regard to the within zero question, it was more using it as not within zero. For example, privilege not within zero of boilerplate privilege boilerplate in quotes. So in that situation, like we're still treating both sides of the proximity as a single phrase. It's just remember that you do have the not condition there. So what that would actually be searching for is it's going to look for privilege. If privilege doesn't occur in the text, we're not going to give it a hit. If privilege does occur in the text, then we'll look and see if it's within a certain distance of boilerplate privilege boilerplate. If it is within a certain distance, we will also not return that because you're choosing to do not within. Keep in mind though that like it's not looking the other way, so it's not symmetrical. So it won't be looking for if boilerplate exists, and if it does, then find if privilege exists and return that. So that's just one of those like differences between not within and the regular within. All right, so I think that answers all the questions that we have for today. If you do have anything else on the webinar, please don't hesitate to send anything into support. We're happy to answer anything that does come up after you get a chance to look at the slide deck. Otherwise, thanks for attending. We really appreciate it. Thanks for all of the great questions that you had. Have a great rest of your day.